In the previous episode, we discussed data types, focusing on the most essential and commonly used ones provided in Unreal Engine Blueprint. However, before we move on, we need to address the concept of scope, which is closely related to functions, methods, or procedures. In Unreal Engine, both Blueprint and C++, we often refer to them as functions. Once we cover primitive data types and functions, we will be able to delve into the basics of functional programming. From there, we'll expand our knowledge to include complex data types and eventually explore object-oriented programming. Before we dive into functions, let's clarify what void means. While it may not be considered a data type per se, one could think of it as an empty data type. It is typically used when a function doesn't need to return a value. In programming languages, void is often placed before the function name instead of specifying a data type. For example, void my function instead of float get my float. The distinction between variable and function declaration lies mainly in the use of parentheses, as functions always require a data type to be specified. Inside the parentheses, you can define your own parameters, which are similar to regular variables. For instance, float a minus b, float a, float b, or void delete string, string my string. In Blueprint, these distinctions are less relevant since variable and function declarations are managed through the user interface, providing a different way to differentiate them. For those who may have noticed that primitive data types like float are written in lowercase while complex data types like string are capitalized, please stay tuned for future episodes where we'll explore this further. Now, let's finally dive into the topic of scope. What is scope, and how does it relate to variables and functions? Scope refers to the visibility or validity of a variable within a certain region or context. Functions can also have their own scope, but we'll cover that in later episodes. This means that a variable exists within a specific scope and is not accessible outside of it. For example, variables declared inside a function are considered local variables and are only valid within that function. On the other hand, variables declared outside of a function have a global scope and can be accessed within the function as well. The scope is determined by the declaration location of the variable. If two variables with the same name exist in different scopes, the local variable always takes precedence within its own scope. For example, if we have a global variable, int x, and a local variable, int x, within a function, only the local x will be valid inside that function. However, you can still access the global x by using class references. In languages like Java or C#, this is achieved through a self-reference called this, but we'll cover that in another video. The concept of scope exists in both Blueprint and traditional programming languages, and it is crucial to understand. If you have any questions about scope, please feel free to leave them in the comments. Finally, let's apply what we have learned from today's and the previous episodes. We will explore the usage of different data types in conjunction with functions, while being mindful of the scope we are in during programming and when casting may be necessary or problematic. For this purpose, I have created the following scenario. As players, we should have health points that can be deducted as desired. Additionally, we want to display the current health points using print string. Which data type can we use to implement the health points, and can we easily cast it to a string? The answer is that we can use either integer or float. We could also use byte, but it's important to note that in this case, we would have a maximum of 255 health points and cannot have less than 0. For this example, I will use float. This can be quite handy, as we will discuss in future episodes. Converting float to string poses no problem either. To deduct the health points as desired, we will use a function. We won't encounter any scope-related issues here since we have declared the health points variable as global and passed the amount to be deducted as a parameter. We don't need a return value since we set the health points within the function. Next, we will navigate to the project settings and under the Input tab, we will add an action mapping. Let's name it Use, and then click on the keyboard symbol and press the F key. Then, in Blueprint, we will add the Use action input and bind it to our function, subtract health. We will deduct 10 health points. Furthermore, we will add a print string node to our tick function, set the print duration to 0, and add an append node. With append, we can concatenate multiple strings together. You can add or remove pins as needed. In the first pin, we write health, and we add current health to the second pin, which will automatically convert from float to string. Lastly, we need to change the default pawn from BP_P_custom to BP_custom pawn in our custom game mode class. Now, when we start the game, we will see our health, 100, displayed in the top left corner. Pressing the F key will deduct 10 health points each time. In the next episode, I will demonstrate how to implement what we have done today in C++ and discuss why such fundamental mechanics may be better suited for C++ than Blueprint. Thank you for watching.